Hey, what's up, guys? How are you today? Now we are going to talk about PLC communication, ModBus master and slave in that data exchange. We will begin with a new project. I'll be adding a new CPU, the 2FMO1. I will drag and drop the icon over here to the main screen. Then I will add the communication card on CM PTP RS422. I will drag and drop the icon to the main screen again. And the next step is to double check the module parameters and make sure that we are using the correct configuration. 2 wires, 9600 bps in transmission rate, 8 data bits, no parity. Okay, ModBus, it's correct. 9600, it's correct. Parity on, 8 data bits 1. Okay, scroll down to the bottom. Everything seems alright. Down. No more options to select over here. Let me check again. Half duplex, okay. Part configuration, okay. Diagnostics. And frame IO addresses, okay. So moving forward, I will open the OB, the main OB. Okay, double click, right click the CPU, and I will disable some safety configurations that I don't need right now because I will not be using on this project. Okay, I will also enable the system clock and memory bits because those are very useful for doing everything in PLC programming. We enable the simulation option over here, okay? And here we have to use 2 data blocks. The first one is the ModBus COM node. This is where you do some setup, and after that you are able to use the main ModBus data block, the ModBus master. And this open context over here is quite important because this rack pin enables the data block itself. This configuration is only meant to be executed once at the first PLC scan.
That's why you will see when you check well, like this one, you see it been eating on the leaf.
In the remaining pins, I will self-reference the block itself, pointing to its internal variables. This is quite basic. The name on the right is the same name as the left after the period. Now pointing to the internal variables again. This section is the last one in the bottom left, where the data that we will read will be placed. And now the ModBus master block. Inside this block, it's where we do everything else later. Now I will copy and paste the block name from here to here. This basically points the configuration block where the configuration needs to be done. Pay attention to the .mb, okay? Here, I will add normally open contact, a trigger condition to request data from the network. Now, pointing to the block internal variables again, the exception is the last one in the bottom left, where the data that we will read will be placed. And it's time for the data block, which will contain our pulled data from the network. I will name it my data. Internally, it will contain a variable called data from ModBus. Data type array of words. And as I said previously, our exception now will be filled. I will just put this array in the data pin of the ModBus master block. Now, here is the ace in the hole. If you press F1 and take a look at the help, there are some internal data block adjustments to be made, and here we go. Port should receive the hardware identifier of the communication module. Here is where you'll find this number. "257" is the hardware identifier from this module. Just copy and paste it over here. "9600 0 0 1000", just the default values so far. And over here, mode, if we take a look at the help again, the mode should be 4, because we want an RS485 communication, right? So let's put 4 over there. And changing to ModBus Master DB to change the configuration. And here we put the station address to be read. My slave device is set to 1. And let's check the help one more time. Now we have another mode option here. If we want to be reading a holding register, put mode 0 because we are reading. If we were writing, it would be mode 1. Or data length of, let's say, 2, and data address of the device, that should be 40,001. And here I did a small mistake. Data address is not 1, it's 40,001. And now let's try to compile, and it's complaining that our my data block it's not compiled. So right click it and rebuild it. And let's compile again, and it's done, no errors. And let's send a download to the PLC, and since it's a new project, it will search for available PLCs in the network. It found one PLC. I will click load. It's asking for me to change my adapter network address to an IP within the PLC range. And here is where I correct the data address, as I've said before, 40,001. And then it starts pulling data. And let's check the real world equipment. Finally,